In this lesson, we're going to examine some ideas about finance. In particular, we're going to look at currency conversions and simple interest. Start with some basic ideas about how we can work with money in an international way. So one of the simplest things we should be able to work with is currency conversions. We have Canadian dollars, we want to convert them into American dollars or pounds or euros or things like that. And we can do this by setting proportions. That's probably the quickest way. Okay. We're told that one US dollar is worth 1.0326 Canadian. So I can turn that into a proportion. One US dollar goes with 1.0326 Canadian. In part A here, we're asked how many Canadian dollars could be bought with 250 US. Well, I'm told 250 US. I want to know X Canadian. Only thing to be careful about here is that you have the same kind of units on the top as you do on the bottom. Okay, to solve these things, we can cross multiply. 1 times X is X, and 250 times 1.0326 is $258.15 Canadian. Okay, just solving related rates, proportions. Okay, in part B, same idea. How many US dollars can be bought with 100 Canadian? So take the ratio that we know, 1 US, 1.0326 Canadian, and this time we're asked about 100 Canadian. So to match our units, it's got to go on the bottom, and our X will go on the top. We'll cross multiply again. 100 equals 1.0326x. Divide both sides by 1.0326. And we should end up with $96.84. And that's in US. So I'll move this over here just so I have my units in here. US. Okay, just real quick, simple solving stuff. So try another one. We got Sven. He's traveling to Europe. He withdraws $800 from the savings, converts it to euros. The bank is buying euros at $1 for every 0.785 euros. And they're selling them for $1 for 0.766 euros. How many euros will Sven receive? So we got to interpret this question a little bit. What is Sven doing? He's buying the euros, right? Which means that the bank is actually selling them. So I need to use this conversion. $1 goes with 0.766 euros. What does he have? He has $800. I want to solve. So cross multiply, and we'll end up with 612.80, and those are euros. You just got to be careful with interpreting the question, that one. In part B, trip's canceled. How many dollars will he receive if he converts the euros back? Well, now the bank has to buy his euros from him. So we have to go to the other equation this time. So $1, and they're going to buy at 0.785. What does he have? He has euros. He has 612. Oh, that's 21. 612.80. And he wants to know how many dollars he can get back. So we do our cross multiplying again. 0.785x divided out. And he ended up with $780.64. So by making this conversion, he's actually lost money. The bank has made some money. Part C asks, how much has he lost? Well, start at 800. He's down to 780.64. So he's lost $19.36. Oh, no, 19. Yeah, 19.36. And the second part of that says expressed as a percentage of the original 800. So if I take 1936 and I divide it by 800, I get 0.0242, or in other words, 0.0242, 2.42%. Okay. Now, why do we do that conversion at the end there? Why do we take a percent? Well, that's a handy idea. That idea is the idea of commission. Banks earn money on making currency conversions. They call that commission. It's generally a percentage of what you started with. So if we say we're going to convert your money for you, we're going to take 1% of it. You have $100, they take the first dollar. Okay, so you lose money in the conversion because you're paying the bank to do the money for you. For example, we've got Jin traveling from Korea to Japan. The bank sells Japanese yen at a rate of 1 Korean won per 0.1219 Japanese yen. Commission is charged at a rate of 2%. Jin pays 1 million Korean won. How much does she receive? Well, she's got 1 million Korean won, but she has to pay the bank right off the top 2%. So as a decimal, 0.02. That's going to give us 20,000. That's the money she's losing. This is our commission. So what is she actually converting? She's converting the difference between those. She's actually taking her $1 million, losing our 20,000. We're converting 980,000 Korean won. So how much is she going to receive? Well, let's do our ratio conversion here. We got 1 Korean won, told that in the question, is 0.1219 Japanese yen. And we've got 980,000 Korean won. Let's do the calculation. So 1 times x is x. 980,000 times that decimal gives us 119,462 to the nearest 1 Japanese yen. Now, you could also have done your conversion and then taken commission. And we'll come up to the exact same number. I just like to take the commission first so I know what I'm dealing with. But it's your choice. All right, second idea for today, simple interest. Simple interest is the idea of we put money in the bank is going to pay us for leaving our money there. Or we borrow money from the bank and we have to pay the bank for borrowing their money. It's the cost of borrowing. Okay. Simple interest is one of the 2 types of interest we're going to look at. We'll also look at compound interest because that's more likely to be seen in the real world. Okay. So the simple interest formula made up of 4 letters. I stands for interest, how much it's going to cost us, or how much we're going to get paid for doing this. C will be our principal, how much did you start with? R is our rate, that's your percentage, but we always work with percentages as decimals. And N will be our time in years. Now, the way we're going to create the rate as a decimal is we have to divide by 100. So really, all we're doing here is creating a decimal. So if you're told 5%, we'll do 5 divided by 100, and then we have our percentage. Okay, we're going to try some. So we have $1,225 to invest. That's our principal. We're going to do this for 3 months. Now N is time, but it's time in years. So they're telling us 3 months. That's a portion of a year. A year has 12 months in it, so our N is 0.25. And our rate is 5%. So when I go to my interest equation, my C was 1225. My rate, we said it's 5. My time is 0.25. And I'm going to divide that rate by 100 so I create my percentage idea. Put it all into your calculator, and you should end up with $15.31. Okay, now, some people like to do that conversion, the 5 divided by 100 right off the bat, so they can just deal with decimals. But the formula we're going to be given or working with is it's written with the 100, so it's kind of your choice. Try another one. Hang on. So we have Josh. He gets his monthly MasterCard bill, $423.89. MasterCard charges 16 3/4 interest per year, and Josh is 16 days late paying his bill. How much does he owe? Well, he started with $423.89. His rate is 16 3/4, in other words, 16.75. His time is 16 days. Now again, time is in years, so I got to divide it by the appropriate number, in this case 365 days. So interest 423.89 times 1675. I'm going to leave this fraction 16 over 365. So, oops, 65. So my calculator will keep the exact number in there. And I'm going to divide it by my 100, changing my rate to a decimal. If I put that all into my calculator, I end up with $3.11. Now what is that? That's the interest he owes, the additional amount that he owes. So the question was, for Josh, how much does he owe? He owes, well, the part that he started with, 423.89, plus this new interest that he just accumulated. So he actually has to pay back $427 now. That doesn't seem like much, but it's just because he was late, right? The longer he keeps it out, the more interest he's going to accumulate. Now we'll try another one. We got Susan. She has a $2,000 investment. It paid her $215 at the end of the year. When we talk about being paid at the end of a year, that's our interest. So we know right off the bat we have a C, principal of 2,000, and interest of 215. Show that our simple interest rate to 3 sig figs was 10.8. Okay. And we also were told end of 1 year. So they're actually told all the numbers we need, we just got to prove it. So I'm going to do it by actually solving for it. We have our formula, I, which we know is 215, equals C, 2,000. I'm going to say I don't know the R right now, though I know what's supposed to be. Okay. And my N, all divided by 100. On the right-hand side, I can multiply all the stuff on the top together. 2,000 times R times 1. That would be 2,000 R. Just multiply together. And I can divide that by 100, which gives me 20 R. If I want to solve for R, I can do that. 215 divided by 20. And sure enough, when I do that, I get 0.105. Oh, that's right, 108. Not 5, 108. Well, out of 3 sig figs, that is 0.108, or in other words, 10.8%. Exactly what that's supposed to show. We can solve for any parts of the simple interest formula, the R, the N, the C, the I, as long as we know 3 of the 4 values. Generally, we use it going forwards, but we can also work backwards if we need to. All right, let's look at the last one. We got Carrie. Her investment matured today. In other words, she's getting paid interest. She invested $12,500. There's her principal. She earned 5.5% simple interest. There's her rate. And received $12,671.88 at maturity. So what did she get? She didn't get this much interest, but her interest is the difference between what she earned and what she started with. So if I take what we end up with and I subtract what I started with, I will always get my interest. The thing I don't know this time is how long it took to do that. So we're going to solve. So our interest, 171.88, equals our principal times our rate times our time divided by 100. I'm going to multiply together everything on the right side and then divide it by 100. I'm going to end up with 687.5 with an N attached to it. If I divide both sides by 687.5, I end up with N is 0.25. Now remember, time, which we just calculated, is always in years. So the question asks us how many months. So 0.25 years times 12 months will give us 3. And I can make a conversion to any other value I need also. If I had asked was in days, I times by 365, or weeks times it by 52. We should be kind of aware of how many days, weeks, months there are in a year. And that's the end of that lesson. Again, there's a handout for this lesson. Print it off, give it a try. If you're stuck, come see me.